Hey everyone, how's it going? Today I'm going to show you how to use selfup-rejs, which is a tiny little file-based database that stores key value stores over series that I created in a weekend, and I had just Cheek refactor it. Well, he actually asked me if he could refactor it and added some tiny bit of functionality that helped the future of the database itself. The reason I made this was to learn about the FS module in Node.js. Not many people talk about how to write and read from the file system with things that come with Node, and also to help me in future hardware projects with like a Raspberry Pi, an Arduino Uno with an SD card, um, small little projects like that, even just a small production app really on DigitalOcean or some sort of VPS. Um, it doesn't require like crazy setup. You do npm install selfup-rejs dash dash save and you have it as a dependency and now you can use it. Um, there's no crazy Mongo setup or Postgres setup or things like that. Um, this is like an ORM slash database at the same time. I give you a really nice public interface, super easy to use, so I'm going to walk through that and also explain why this would be nice to use for hardware as I go along. So let's go ahead and read the test, or let's run the test real quick. There we go. I have 6 tests that seem to prove all of my functions. So the way this works is we'll do a get table and new data. So this tests both that I can append new data to a table and then get the entire object from the table. So here I have test 1 with test data 1, test 1 table with test data 2. So if you look at create table, I take a table name. So before each, I always create a new table. And then after each, I always drop table. So the crazy thing is that like to test this, this had to be created and this had to be created. Otherwise, I'd have to do some janky stuff in here to prove that it works. So it's kind of cool that the functionality was there to where I can have an essential database cleaner. Cheek helped me with writing the test. I thank him much for that. So let's get started. So first, not only do we create a table and give it the table name, now we do new data. So how does this work? I give it the table name and then I give it the JSON object I want it to store. So when we go here, I give it the table name test1 that has been created, and then I append the new JSON object that says test. It points to a string that says test data 1, test data 2. I expect when I do a GET request, essentially, that I get an entire object with test data 1, test data 2. And this also shows you the metadata that is inside. I originally had these pieces. Just Cheek decided to add this so that I don't have to iterate through the entire table or the objects, because imagine if the table had, I don't know, like 100,000 records. I don't want to have to iterate through that to figure out that the next ID is going to be 100,001. I just wanted to be able to go fetch the metadata and be like, oh, the next ID when I make one is just going to be 3 in this instance. So now I assert deep equal. That expected is what I get when I do a GET request to the entire table. You can think of tables as endpoints. There's no real HTTP going on, but it's an easy high-level way of thinking about it. Here I do a where. So this isn't a relational database, but I was able to figure out how to do a where clause or a where query. So I add in test data 1, test data 2, and then I do test data 1 again, so that when I do a where I get 2 objects back. And then I have test data 4. So I expect an array, which is great for like front-end libraries like D3, P5, stuff like that, because they like to chew through arrays of objects. So that's really easy. So now when I do a where, I can do test 1, data 1, bam. I'll blast through these tests real quick and just show you how to do it in the quote-unquote console, right? The console is simply, I do node, and then I make sure I require the file, instantiate a new database object, and then we can start having fun and creating tables, things like that. So delete by ID deletes an object by its ID. Find ID just finds an object by its ID. Update table. So this is more like Mongo-y. I can immediately say to myself, oh, I don't need 100,000 records anymore. I just need this new record because that's all that matters. So I can update the entire structure, and I'll show that to you in real time, and it'll make a lot more sense. And this is just like a small little benchmark. On Cloud 9, it seems quite slow, 118 milliseconds, but on my MacBook Pro 13-inch, sometimes I don't even get the millisecond warning, which means it's supposedly under 30 milliseconds to do 1,000 GET requests on a table of 10 JSON objects. So that's pretty cool. For something like a Raspberry Pi, that's really all you need. So let's get started. Let's do const, and I'm just going to say selfup equals require read.js, because that's the file name. Alright, so now we say const vjs equals view selfup. Boom, we have a new object. So pay attention to this folder here. I'm going to do vjs.create table, and I'm just going to call it wow. It's easy. And now when I go here, I have wow. So now let's take a look at what that does. So just like in the test, I expect some metadata. So I just created a table, and I have basic data so that my database can do some work when you want to add new data. So now we're going to do new data, and we're going to give it a little object. We're going to say test. This is a test. Spaces. All right. Oh, sorry about that. Okay, so we're going to have to do this over again real quick. Sorry. I hit Control D instead of Control C. Alright. Okay, let's create this table. It won't freak out if it's already created, which is nice. Now let's do new data. And I'll make sure not to hit enter. There we go. Okay, now it's an object. So now you can see that it appended with an ID of 1. Test, this is a test. So I can keep appending. So the idea here is that this is essentially a series database. Not through time, but just through events. So it's like an event-based DB that has some relational values. The where statement helps. So yeah, I guess it is an event-based. So the idea here is that you can have like a user, or you can log all the temperatures in your house at the same time every day with the Raspberry Pi and some kind of temperature sensor. Store this in the DB, and so like using node bots with Node, and you can easily put this inside. Then you can do where statements, or you can just take the whole object with the GET request, iterate through all of them, and figure out the average temperature. It's like a really easy way to organize your data and have it persist. If we do update table, this is pretty much a patch or an update, or put, however you want to say it. And now there will only be one object again, because I updated the entire table. So I automatically, or the library automatically puts the metadata back in there and then appends the new object. So it does a little bit of work. We can drop a table. So let's drop table wow, and now it's gone. So see, it's no longer available. Nope, let's not keep it open. And now let's create it again. Alright, so we just recreated the table. I guess I'll just show it to you on the left side now. And let's do new data. This is a test. This is a test. 3 times, and then we'll say this is a test 2. This is a test 2 twice. And this is a test 3 once. So now we have a bunch of data. Yada yada yada. So I guess I can close this now. Should probably save it. Yep. Okay. So now let's do a where. Where inside of table wow, I find any string at the top level, this is a test. So if you have a nested object, it won't find it inside of the nested object, but if you have like primitive identifiers at the top of an object, it'll easily be able to go find and return a collection of all of that. So now I have an array of 3 objects. So if we do test 2, there will be 2, and then if I do test 3, there will only be 1. So it's pretty neat. It's actually really fast, even considering that this is like a VM in the cloud. So it's much faster or more performant, at least on an actual machine. Not saying that this isn't, but you get the gist. So we can drop tables. Let's just create another table so you can see tables on the file tree over here and just get appended. Let's call it LOL, OMG, stuff like that. So these have nothing in them other than the metadata. And it lets you know what table it comes from, stuff like that. Also, another interesting thing that had to be implemented when creating this library was the private methods in ES6, because I'm using ES6 class here. These are very useful, and if you know what you're doing, like you completely understand how the database works, you could do this. But unfortunately, if I didn't want this to be part of the public API so that people wouldn't ruin their database or something. So I was kind of surprised that there was a way, at least in ES6, to make private methods. So the idea is you make a symbol and then you rename those methods with brackets, underscore, like the symbol name. And then when you call them in your code, when you call like this dot, instead of using dot, you simply do this hard brackets, and then you can still pass it to parameter. So that's pretty cool. So yeah, if you can see some use case for this, go for it. Note that this does not work, well, it does work on Heroku until you restart, because all of your new data is not in your Git history or committed. So the second you restart or push a new feature to Heroku, it'll just completely ignore that. It just pulls straight from master. So that data will be gone. However, if you have like a droplet or some sort of virtual private server, this data will persist. Raspberry Pi, it'll persist. Arduino Uno with an SD card, persist. BeagleBone, etc. And like right now, I'm reconnecting apparently. So good thing this worked out before Cloud9 decided to go bye-bye. Okay, so it's back. So here's my package. I released it not even 24 hours ago, and there's quite a bit of downloads, so I might have a second job, so to speak. Here's my repo. If you want to clone it, go for it. If you want to fork it, go for it as well. If you want to add any features, I consider this database pretty much complete. This database was built with developer freedom in mind, so it only does a couple basic things, and you can chew the data up however you want on your client or the server, whatever. This is me. Feel free to hit me up on GitHub or my email, whatever you want. Oh, it seems that my internet is slow. Interesting. I've never had issues with my internet here. Today would be the day, huh? But anyways, yes, I make a lot of stuff. I've only forked a couple things. Okay, so my internet's gone. That's okay. So either way, if you like what you see, let me know. Remember, this was more of a learning experience for me. This isn't a very serious database, but if you want to take it seriously, feel free to post issues if you run into anything. Otherwise, have a great one.